So welcome everybody, live from New York. It's Friday afternoon. Uh, we welcome you to the May ReproNim webinar series. We are delighted today to have senior ReproNim faculty Grethe from the University of California, San Diego, who is co-director of the FAIR Data Informatics Lab there. Jeff's work includes extensive development for technical infrastructure and informatics networks for searchable open source neuroscience data and resources, as well as a long-standing dedication to the establishment and oversight commitment for data standards and data sharing. So many of us in the ReproNim team and community are well aware of Jeff's work, so I'm going to just turn the floor over to Jeff to tell us about ReproNim and NIDM and whatever he thinks we should know. Thank you, Jeff.
Thank you, Dave. So what I'm going to do today is sort of give a very broad sort of soup to nuts walkthrough of, NIDM, related to, how that makes neuroimaging data fair, but also how then, that can, as we're working on now, how that can actually bring sort of AI techniques to the data. And again, the AI portions are very experimental and are not yet in the main PyNIDM branch. They're still in development, but I just wanted to foreshadow that a little bit. So, if anyone's been following ReproNim, we do have, a set of principles, to really support the full neuroimaging workflow, and that's from, data acquisition through the analyses derive data through publication. And as Dave had alluded to, that really touches upon standards, the provenance for how that data is handled, and even on the analysis side, the use of containers, versioning data. So, I think a number of people probably had have listened to Yarick's webinars, around data lad and containers. So there's a lot that goes on within this workflow, to that needs to be documented to ensure that the data is usable. And so the main thing for larger frameworks for data, is fair. And so that is, to make sure that the data is find accessible, but the two most important aspects are interoperable and reusable. And so that you have sort of unified views of, certain data so that the data is properly aligned, and that meets community standards, for representation of these resources. Now, FAIR was, put out as something, as goals to attain, but never sort of specified what is needed to actually make it happen. And so, communities themselves are working on, defining, what is needed for FAIR. In terms of neuroimaging data, there are a number of standards that are related to that, but I wanted to put this in the context of, what people might also have heard a lot about in terms of, data lakes, and how this all sort of comes together. So, when one thinks of data lakes, this is sort of a way to represent, a store of different types of information from, very structured information, from databases or semi-structured data, so for example, CSV files, logs, XML, even unstructured data, and binary data itself. And so, what we want to be able to do, is basically take the various pieces of data that exist within a neuroimaging workflow and tie them all together, so that they are in a uniform way described. Now, when we talk about sort of this concept of data lakes within ReproNim, we have two types of environments. There is your local environment, so your local store of data and metadata, which we refer to as a ReproPond. And then there's sort of global metadata stores, which one might consider to be a Repro Lake. And what we look at in terms of how the various ReproNim components tie together is this flow of data through analysis and compute environments, how that metadata and provenance ends up in the repro pond, and then how this data can be published to a repro lake. And now there are a number of tools that that I'll sort of walk through today in the presentation, and that primarily behind what we're doing within ReproNim. There is NIDM, which sits on top of BIDS, and then how NIDM sort of relates to query frameworks like Sparkle. And then also, work of, groups, that we are working with in ReproNim, such as Neurobagel, which is, work with Sebastian Erks and JB Pauline, and others, and how that, provides sort of a graphical user interface across standardized data. So your repro pond. So again, there are motivations for structured data. There are many, different types of data that are being collected by subject. There are different ways that data might be arranged. There's difficulty sharing data within and across large projects. And so there is just a lot of potential, differences, with data. And so, the first underlying principle for having standardized data is BIDS. So BIDS provides the structure which we can layer everything else on top of. And so BIDS is well adopted standard within the neuroimaging community. And then on top of that, we can push additional descriptors through NIDM, so the neuroimaging data model. And there are different aspects to the NIDM specification. So there's a specification around the experiment itself. So, parameters, used for collecting, the imaging data, how subjects are associated to the various images that are collected, what types of assessments were collected on those subjects. Then there's also the workflows and the results, where we can document the image processing and resultant data. And this is built on top of a family of semantic web and associated standards. And BIDS and NIDM, are synergistic in the sense that, again, NIDM builds on top of BIDS. So, for example, in BIDS, you have your participant TSV file and might have different files for various assessments. NIDM can bundle all that together in a structured format so that all subjects and their various assessment data are linked together in structured triples. And I'll get to that in just a second in terms of introducing RDF itself. So NIDM, again, built on top of RDF standards. And basically, this comes from, originally from, the vision for this from Tim Berners-Lee, where, a semantic web, is, this linked set of information that is understandable by computers. So it's based on a set of linked data principles that uses URIs as names for things. So URIs are just like URLs. So they are unique identifying objects for various entities. And so if you were to look into a NIDM file, you'd notice that each participant, for example, has its unique URI associating itself with that subject. So that subject can be uniquely identified across, all the triples that are being generated for the various subjects, data, and the like. And the RDF is, a World Wide Web specification, and is used through a sort of stack of technologies, and so there is query languages that sit on top of that, such as Sparkle, which I'll get to in a second. And this is again building on sort of these open standards for RDF. And so the specification itself, if anyone's interested, you can find it at w3.org. But basically, everything is built on the concept of a triple. So this is, a very general syntax for representing this data, where you have a subject, predicate, and object. The subject itself is a resource, again, identified by a URI. The predicate is, what is the relationship to an object? And so here, what we see, this is from NIDM experiment, an example where you have a subject, which had acquisition modality of magnetic resonance imaging, just as a very simple, example. So subject, predicate, object. And so this is how all the data, within an RDF is generated. So everything is built off these subjects, the links between them, which is the predicate, and the object, which, again, the object can be a subject of another triple. And the vocabulary, that is used within RDF, right? There can be different types of terms, right? So you can have, again, the relationships. You can also have attributes that are associated with various triples. So, for example, you would have, with MR acquisition, you would have information on how that acquisition was acquired in terms of parameters used, and those would be various attributes themselves. So they would not link to other classes, but they would link to the attributes, the specifics themselves. And so again, when talking about RDF, the class is the subject, the scanning session, the data file that we're talking about, the relationships between classes, and then the properties, of the various class. So again, in terms of the echo time, for example, of a scan. So this is all represented within an IDM experiment, and this is where you have the representation of the experiment design, the source data descriptions, information on the participants. You can see here just sort of a simple hierarchy, that is generated, as part of, potentially defining this. In the latest PyNIDM version that is being developed right now, so this is the work of Dave Keeter, there is, ways to graph, very fully sort of the NIDM graph of the data that you have acquired. And when one looks at the actual file itself, where the data is stored, so this is, NIDM experiment in RDF, and this is, a turtle representation, you can see that, you have at the top here, you have a subject, right? Or you have the acquisition object. So you have a scan. You have the various information about the DICOM parameters, and you'll notice that they use a DICOM prefix. So again, one of the best practices with generating RDF or any type of data is to sort of reuse terminology, reuse ontological information. And so that's exactly what we're doing here, where we're reusing DICOM terms for what comes from DICOM, and then we have the NIDM information as well. And if one looks at sort of a larger example of an RDF graph, you could have, for example, a project that has a number of sessions with the various subjects having their image acquisition, and you could potentially do a free surfer computation, which links back to a number of the scanning sessions. And when that free surfer results come out, then you actually have information, about, for example, break grain matter volume, and that itself could be linked to an ontological term that defines what that is. So again, we're taking the data, we're trying to provide context around the data and provide descriptions of what the data is. And, there's, again, a number of tooling, that is built around NIDM. And so that is PyNIDM, and, Dave Keeter has also done a number of webinars, with, through ReproNim, but also, the ABCD ReproNim short courses, where he has gone into much more depth, about NIDM and PyNIDM, which I can't do today. So again, what I mentioned earlier, reusing RDF vocabularies, is something that is, beneficial in that it aids interoperability, so that, when people define things using sort of shared vocabularies, that they can be then more easily integrated across graphs. So how do we annotate data? And so here again, we get to PyNIDM. So the PyNIDM tools, basically provide tooling from, when you first get your data all the way through to the potential querying of the data itself. And so there is, initial, for example, conversion of, bids data to bring that into the NIDM data model. So that is, basically the first step is to, convert, bids represent data set into NIDM. That then, can lead to, here are a couple query examples, that I'll talk a little bit more about down the road. But, PyNIDM you can get at the GitHub repo, along with all the documentation as well. Within ReproNim, so this is the new website that we've just stood up. There are a set of tutorials that cover various aspects of conversion of data. One of them is, for example, annotating free surfer data. So I gave the example before that you might have data that you analyze with free surfer, but then how do you get that into a queryable form? And so the way to do that is there is a set of tools within PyNIDM to allow you to go through the free surfer results and bridge that into the data that you may already have in the NIDM format around your subjects and the scans on those subjects. And so this is the SegStats JSON-LD tool, and so basically it takes the free surfer subject directory as input, parses the files and encodes them as NIDM, and then adds that to existing NIDM records. There's also documentation for FSL on the site. And so again, these are different ways to bring data in to this more structured form. But one of the most important aspects of bringing data in relates to information around the various participants themselves, because this can be highly variable. And so there is also tooling within PyNIDM to assist with that, and that is to bring that the bids participants files into the NIDM form, and that is NIDM CSV to NIDM, and it's really used for creating data dictionaries and the associations to concepts to bring that into NIDM itself. And again, the further documentation for that is available on via PyNIDM itself. So when one looks at sort of the NIDM, the full sort of ecosystem, there are a bunch of annotation tools for NIDM experiment and also for the NIDM analyzed data. This pulls information from ontology sources such as Interlex. That's something that we have developed out of our laboratory, and again, that these then sort of annotated data then get bundled with the BIDS data so that there is this structured content sitting with the BIDS data itself. Now we've extended the annotation of sort of free surfer data, for example, and the CSV data to allow bringing in, any structured data. And so what this brings in is the concept of a data dictionary. So in addition to having a data file of resultant data, for example, CSV file, you can specify a data dictionary for metrics being extracted, the software pipeline information, and that can then import this data as well into the NIDM files. So again, what we're trying to do is create a base of tooling that can bring in data into structured NIDM, that can then be used by tools on top of that. So within, for accessing NIDM data, since it is RDF, the common query language for this is Sparkle. So this is the RDF query language, and for example, this is also what sits behind Wikidata, and so it's another World Wide Web Consortium sort of recognized standard for query. And it is a way to query RDF data. Now, again, there are different types of graphs. So, a lot of people are probably, also familiar with Neo4j. Neo4j uses, a cipher query language. So Sparkle is specific to RDF, and also OWL, which is the web ontology language. And again, there's more information, from W3C on the different aspects of Sparkle. But what we, in terms of querying, what we focus on particularly is select queries. There are other types of queries, where you can do additional types of functionality. So, for example, construct queries, basically can take a query and help construct a new graph out of that, just as an example. But with select, you basically have some standard aspects to the query. So the first part on the top is a definition of prefixes. So again, if you noticed in the prior example of the RDF data, you had DICOM colon, you had NIDM colon, and so basically these prefixes define the URIs where this data comes from. And so, for example, the NIDM colon types of identifiers, those are all, all these types of identifiers with the colon are considered to be query identifiers, and they can be expanded based on these prefixes. The next type of information looks a lot like sort of a standard SQL query, where you're selecting items, values, variables to be returned. So similar to SQL in that sense. But then the where clause is where things get different, because in the where clause you're not selecting just on sort of column-based, value-based decisions, but you're looking for things that match graph structures, right? So you're looking for sort of, things where graph structure matches what you put in your query. And so here, what we're looking for is that, we're looking for various measures, right? So we're looking for a measure which has a certain URI. And again, this is where things get, in Sparkle get a bit complex because a lot of this is based on, the URIs themselves. And what we're actually looking for here is a volume around that was generated from FreeSurfer, and has additional associated information. So, for example, the laterality of that measurement. And then at the bottom, we're filtering for a specific Uberon tag. And so Uberon is an anatomical location. And here, that is going to, pull FreeSurfer results from that specific anatomical location. And again, can't get into many details of Sparkle queries because it is quite complex, but just trying to provide a high level overview of Sparkle itself. So if you've collected your data and you've annotated it with PyNIDM, how do you actually query that data? So there are a number of methods which have been built into PyNIDM. So there are parameter-based and REST-style type queries, and also Sparkle type queries that you can do via PyNIDM. But you could also, if you're have the ability, you could also run, for example, your own local Sparkle store. So again, a special database to hold RDF data. So for open source version, for example, there's BlazeGraph, there's others where you can load NIDM files and use Sparkle to query that. So in regards to PyNIDM, there are a number of parameter-based queries. So here you could, query, various .ttl files. So again, a .ttl file is a turtle file, and so that is a file with RDF data that's formatted in a certain way. There are different representations for RDF data. Turtle is one of the more common ones that is used because it's also more easily read by humans as well if you're looking at the data itself. Here, example of various parameter-based queries, but the parameter-based queries, allow users to interact with the data without having to learn anything about the underlying data format. And again, here, is another example of, the query and then the resulting output, right? So here you can see that the example query I had before, returns information, about the tool that was used. So FreeSurfer, right hippocampus volume, what the values are, and so on. And so this is, you can issue those Sparkle queries directly from or through PyNIDM itself by providing a query in a file that can be used by PyNIDM to run against the turtle files. Now, one of the things that we are doing within ReproNim is that we're also trying to aggregate data across a number of different data sources and bring that in. And so that's the idea of the Repro Lake, which is a more global store of information where we have, global data sets such as Abide, ADHD, Open Euro, and the like, and where we've potentially generated additional data, for example, from FreeSurfer or FSL in terms of structural volumes and put them in a location for query. And again, you can generate sort of complex Sparkle queries across that information. Now, with some of the information across data sets are not sometimes easily aligned or are not aligned. And so you can also, for example, do statements within Sparkle to do that conversion for you. And so this bind instruction at the end is something that allows values to be assigned to variables across different data sets. And you can run these queries then. So, for example, this is an example of the Reaper Lake running in Stardog, where we're running a query again around these hippocampal volumes and returning data from the global store. So again, Sparkle is not something very easily used by researchers. The parameterized queries, is something else that makes it more accessible. Another thing that increases access is the use of graphical UIs. And so that is where Neurobagel comes in. And again, this is work of Sebastian Erks and JB Pauline and others who have developed this, and we're working with them in terms of ReproNim as being able to provide a interface to the local data. So through the work of Sean Hatton and Sebastian Erks, we were able now to take ReproNim data and load it into Neurobagel instance. For that to be to basically provide a graphical query on top of the data. And again, this is for a set of specific common assessment demographic information that we can map, right? So again, when one brings data into Neurobagel, there is a harmonization process. So when we develop sort of the automated import, we're limited in terms of what can be harmonized. But also when you're working across large cohorts of data, right? Not all data maps, and what is really needed to drive that UI, to provide that query. And so the nice thing about Neurobagel is that it is federated. So even if you have your local node, right, you can also tie into external collaborators and or external public resources and query that. And so again, there are a number of international projects that are using this. So it's being picked up in different areas, and so really would suggest people take a look and check out Eurobagel. And if you actually have been to Open Euro, you can also see that that is also now being integrated with Open Euro itself. So the big thing over the last couple years has been how can AI assist with queries, with access to data, and can it bridge the gap between between researchers and graph databases? And so, as I mentioned, the problem really is that Sparkle queries, and again, what you saw earlier, those are, maybe medium complex queries, right? So they can be very complex in terms of the queries that get generated, and they require knowledge of the graph patterns, as you saw, the URIs that exist, and relationships, for example, that are derived from the PROV standard, which are used. And most researchers lack Sparkle expertise, which creates a barrier to sort of deep data access. And so what we've been experimenting with is, the use of large language models, to translate these natural language questions into valid Sparkle. there are a couple issues with that. So first being that, a number of years ago, the AI generation of, Sparkle queries was pretty poor. However, over the last couple iterations, that ability has increased significantly. And, as everyone has seen sort of the landscape of AI evolve, those capabilities, will sure get better, over the next months, years. The other issue is, that if you just ask LLMs questions, they also hallucinate, right? So, they might grab information, from wherever they might want to grab it from. And they also don't know, information about the structure of the data that you have. And so basically what we want to do is we want to ground the large language models with the actual data model and data. And so this is a concept called retrieval augmented generation, or RAG. And really, what it does is it grounds the large language model in with information about your specific data, and so that it can actually generate the query, and then use that query against the data itself, instead of having the large language model try to answer the question by itself. So basically what you're limiting the large language model to is the generation of the Sparkle query itself, and then that Sparkle query is what is sent to the RDF store. And again, there are different ways to do that. In other projects, a number of years ago, we developed natural language interface to connectivity information that basically extracts semantic frames from the questions being asked. And so basically, in that instance, what you're doing is you're trying to map a user's question into a specific template query that you have already defined. Now, for connectivity information, that works well because, A connects to B, C connects to D, passing through E, right? So they're very structured data with sort of limited types of questions that can be potentially asked. And so that's why sort of this semantic frame operation works pretty well in that use case. However, with the neuroimaging data and NIDM data, that data is extremely complex, can have lots of different types of information associated with it. And so trying to develop the set of templates for those queries is in itself, very complex. And so that's why direct generation of Sparkle is a very useful solution to that. And so, again, with this RAG approach, basically what we're doing is we're helping the user so that the AI can itself retrieve the schema context, generate, valid Sparkle, and could do any validations that need to happen. And so, how do we inform the AI tools about our data? And this is where we are using LinkML. So, LinkML is an open source framework for defining, validating, and sharing structured data schemas. One can write your schemas in YAML, but then that can be compiled into many different formats. And in this case, each element also carries human readable documentation so that these schemas are both, machine actionable by the LLMs, and other techniques, but also human readable. And so this is really what provides the context to the large language model to generate the Sparkle queries. And so again, there's, a number of reasons why LinkML is a good tool for this. I think I mentioned most of these, but there's also the ability to have standard ontological mappings, and to add various validation layers on top of that. And so the last thing, just want to foreshadow a bit, is what we're then working on in terms of the PyNIDM Query AI. Again, this is experimental; it's in development. We'll hopefully have a sort of experimental version out shortly. It's something that's been being worked on, and basically, Query AI is a module, so another module within PyNIDM, that will let researchers query these NIDM data sets using plain English instead of writing Sparkle by hand. And again, it uses LLM. Right now, it you can use either your Anthropic license or OpenAI. So again, to run this within PyNIDM, you do need to provide your own API key. But then basically we use an LLM to translate the natural language question into the Sparkle query, and really try to produce the system that allows researchers to interrogate their data, even locally, as they've been collecting it, or that they have local, in a natural language way to extract data. Even potentially, do subsequent analyses across that data. And currently, we're using a two-phase approach. So the first phase is really, focused on concept resolution, right? So we need to look at the query that a user submits, and then figure out what are they trying to do. So again, they're going to be using words, like age, left-handed, older, and so basically the LLM has to convert these into appropriate mappings to what would be in the RDF representation. If there are multiple data elements to match, the user actually has to be prompted to select the correct one to use. And so again, here we're resolving the URIs, and together with the NIDM graph structure, which is the linkml generated NIDM schema.json, these are then sent to the LLM, which generates the Sparkle query, and then that is executed locally against the NIDM files that you specify using another Python library. So again, no subject data actually leaves your machine. So you're not actually sending the data to, Anthropic or OpenAI. What you're sending is the query and the NIDM schema. It comes back with the Sparkle query, and that Sparkle query is run locally on your system. And so again, here's just a very simple example, because I know that I'm coming up on the end of time fairly shortly. You basically specify, the Query AI tool within PyNIDM. You attach whatever data file you want, and you can ask questions, for handedness on your subjects, for example. Again, this is a very simple query, so that it fits on a couple slides. And so first it has to identify, the variables and what do you mean by handedness. So here we have to select, the proper handedness category. Once we've selected, the choice for what we want, the variables have been resolved, it can then actually go and generate a Sparkle query. If you specify within, the Query AI, the option to return the query, will actually return the query, so you can actually save this query and run it later again. It's also where those with more familiarity with Sparkle, can debug things if things are going wrong, and then it will return the results for you. So again, it's a start to bringing, building on top of, making data fair through these PyNIDM tools, now being able to leverage the AI to sit on top of that to help generate the queries to access that data. And so again, this is something, that is definitely moving forward, and more work is going to be going on there. But just wanted to sort of give sort of an overview of the sort of the soup to nuts process of data coming in all the way to the use of the AI tools on top of that. So wanted to thank everyone, and I can take some questions.
Great. Thanks so much, Jeff. It's great to have this soup to nuts, beginning to end visualization of a lot of the things that have been going on over the last 10 years. It's great. I'll start the questioning um, a little bit related. So there's all sorts of deep, complex information in the
Mhm.
NIDM, in the model that goes behind this. To some extent, the end user hopefully never has to worry an awful lot about that
Yep.
detail. Only a few people have to care about that. Kind of like, when I use Excel, I don't really care about their XML thing behind it. I care that Excel does the things I want it to do, and who
Yes.
cares? So hopefully, that's kind of the vision we have here, that, a few people who have to deal with interfaces and things know this, but the end user should hopefully never need to know much about this. Is that the right way to think about it?
Correct. That's the right way to think about it. And again, as I, some of the earlier tools. So, for example, the PyNIDM structure queries, right? Again, you know, users aren't going to go in, with Sparkle. Researchers aren't going to go in and Sparkle and query that, right? So there were a number of templated queries that were built into PyNIDM to do common things, right? But again, when one's dealing with the vast amounts of different types of data and the context in which that data can be collected, you're not going to come near to having enough templated queries to support all that. And then building on top of how do you connect people to different stores. So again, sort of the Neurobagel work, in terms of doing, mappings for shared data, right? And then having the graphical interface on top of that to abstract away from any complexities of the data underneath. And now, in this next phase, right, the AI, and, it's similar to, I guess, the evolution of computing, right? First, textual interfaces, graphical interfaces, and now AI based interfaces, natural language based interfaces. And again, that's something that, this structure provides as part of NIDM, the PyNIDM release. The LinkML schema and all that will also be released as part of that, so others can start experimenting. So if you're, more on the experimental side, in terms of developing AI methods and all that, the information about NIDM will be made available as part of that, so others can also start experimenting, and bringing different AI-based tools, out based on NIDM data. So,
Great. Other questions from the audience? If the audience is shy, not that I expect that of this group, we often, in ReproNim, the Center for Reproducible Neuroimaging Computation, get questioned on, all this AI stuff. How do we maintain reproducibility in the age of the wild, nefarious AIs? Do you have any high-level statements in that area?
well, I mean, so again, we aren't. So in terms of the reproducibility of the underlying data, that's captured with the various tools to convert the information into the structured NIDM format, right? So that underlying data has the associated provenance. Now, with the query itself, again, in the RAG approach that we're adopting, we're generating the Sparkle query itself. So you can always store that Sparkle query, right? So you'll always have provenance of what the query was that you ran against your data. So again, we're not using the large language model to interact in a non-structured way with the data sources, right? So it's a very structured way that we're doing the interaction with the large language model, so that we don't get hallucinations, and we have the ability to track provenance of what was the query that was used to generate the information. But again, what people do after that, so if they get return results and then they ask, their large language model to do something with that data, then it becomes much murkier, right? In terms of what it might do into shaping the data or other things. So, but I mean, that's always the case with any analysis, right? At some point, the user has to take precautions.
User in the
So,
loop. Satra,
yes, Satra.
question.
Yeah.
Hey, Jeff, nice talk. I wanted to kind of perhaps probe into a futuristic question. What would it take from going from what you presented to actually asking a question and getting back an answer, not data?
So, an answer in terms of then having the large language model actually do sort of the analysis on top of that.
Yeah.
Yeah. I mean, again, I think that is possible now. Um, the question is, no, I mean, there are different ways to do that, right? So, one of them is you could have, instead of asking the large language model the question directly, right, is asking the large language model for the code to answer that question, right? So again, thinking about reproducibility and how that might be handled. Again, if you just ask the large language model to do something, it will do it, right? How it does it depends, right? But if you do actually have it try to generate code that would take the data and process it and return the data, then you'd have some aspect of reproducibility. But that requires the user to actually re- request that type of workflow. So I don't know if you have any thoughts or best practices, but again, it is sort of at some point I mean, it gets to an educational component, right? In terms of making sure users understand how the LLMs operate and best practices for reproducibility.
Yeah, maybe I'll just say I think one of the challenges I feel is understanding what's in the data lake is
Yep.
still going to be a key challenge. Not because it can't do queries, but understanding what went into generating that
Right.
data into the data lake. And I think that's where maybe it's not that it might not be able to answer a question given a question. And today, I think with some of the agentic platforms we're seeing, all of that provenance gathering and reproducibility can be built in, just as you said, Jeff.
Yep.
It essentially generates code, right?
Yep.
But
Yep.
we're also getting into semantic loops in some of that space where some analysis is done through the LLM lens and some analysis is done through a coding lens. And I
Right.
feel
Right.
that's going to be one of the stickier places for reproducibility that we'll have to grapple with in some sense. What does it mean when the answering machine is a
Mhm.
non-versioned large language model that changes every day?
Right.
Uh,
Right.
but coming back, I think the question I would ask is, so what can we do to improve the quality of data and the precision of data in ReproLink?
The I mean,
Maybe the context of
yeah,
data, because I think that's
yeah. I
where,
think, yeah. I mean, the context and provenance. I mean, the issue is, in terms of the various pipelines that are generating data. What actually went on, and a lot of times, if you're going to be querying resultant data, how many people look behind to see what was actually done? What pipeline was run? What version of software was data run on. So again, I think that is something that remains hidden a lot of times. but would be useful if that is brought out. So
Seems like it would be a good idea to include the QA metrics of the data. Oh, and maybe the pipelines
yeah,
have QA metrics and dashboards and things that they refer to. I wonder who might do that. Oh, ReproNim 3.0. Okay. Yeah. So we're coming up close to the end of our time. If there's any burning questions, reach them out. I see Brent.
one more.
Yeah. So I've had a side project that I've been working on for a while of having an LLM extract Cobitus criteria from an article.
Hmm.
And I've recently kind of started coming full circle if I'm needing to add enough information that I'm kind of working on my own schema for the information needed to pull those features. And I was repeatedly running into NIDM, and this kind of clarified or verified for me more so that I'm kind of coming at the opposite end of from a manuscript reconstruct
Hmm.
the data that went into it. So I'm just kind
Right.
of curious because I am in the process of working on some of this when I find the time. Uh, is that kind of a useful, or is there a use in kind of reconstructing from that end to verify, or kind of an interesting thing there, or is it just a little too unrelated? Because it's, like I said, I'm realizing I'm kind of trying to use it backwards.
Yeah, I mean, you're coming from the article, but and you're extracting the actual. You're trying to extract like some of the protocol information and some of the data that was like the summary data that was analyzed.
Yeah, kind of
Yeah.
categorizing. I'm starting with like the scan criteria because that's always very
Right.
fixed, but in theory, it could also start kind of constructing some of the analysis models that happened. Those are more advanced, but it's like I said, I'm kind of having to. I was using a repro schema that Remy Gao pulled
Hmm.
together for Cobitus, and I'm having to add enough information per variable that I'm kind of restructuring that into my own extractor related instead of a
Right.
form.
Right.
And like I said,
Yes.
the NIDM criteria were useful for helping me kind of conceptualize some of the
Right.
parts, but it wasn't. I was trying to use, like I said, from the other direction, so it wasn't
Right.
as
Right.
immediately
So you
applicable.
said, I mean, but you did mention repro schema, so I actually might pass this to Satra if he has thoughts, since he is the father of repro schema.
I don't know about fathers or mothers. I, Brett, I think in the context of structuring information, which is I think what you're getting at, right? That you're taking COBIDAS. COBIDAS already defines a structure. And in fact, eCOBIDAS was done in repro schema originally. And so from a just a data element specification perspective, all of that exists and probably could be updated if things have changed. And that may be a good thing to kind of pass on to an LLM or to a iterative set of uh, LLMs and other agents to say, hey, extract this information. All the descriptors are there. And the one thing that I would probably add to it is also attach the evidence from the sections of the papers
Yeah.
from which that information was extracted.
Yeah, no, that's the kind of workflow I've been trying to pull together. I was starting with the eCovidus form,
Okay.
and that's what I've been kind of having to augment with what I wanted to store in addition and some other things. And it was kind of, I wasn't able to just ingest the schema and pass it as easily. I was kind of having to add more and more information like per variable I was trying to test. So it just kind of started growing in scope. But yeah, I've had a little bit of time recently to kind of iterate that as a end of the month paid rates were about to expire, so I kind of crunched on it a bit. And yeah, I was curious if there was your takes on some of that because I've yeah, like I said, I kind of realized, and this to help verify, I'm sort of going a little backwards on some of this, but it feels like a useful domain to kind of grow this in. So
And originally when eCovidas was created, the idea was that people would use the repro schema UI to fill it in. And I think we're way past that stage. That was always problematic because asking people to enter information in a form is always challenging. And so in both settings, right, whether people were filling that even prior to a paper submission or post, which is what you're doing in analysis of a paper, I think these tools can help a lot in curating that information space. And hopefully, even if somebody has a preprint, they should be able to generate that ecobidas document. And Reaper schema just is a schema in some sense, right? And so if you have suggestions on improving that, you should pass it along. Or I know there's a repo out there, right, Brent, on
Yeah,
Reaper
yeah.
schema. Yeah. Whatever it takes to enrich that space would be nice. As I said, the one thing that I would love to see is the evidence part of it if this is being automated. And that goes back to, I think, the question Dave had asked around provenance of queries in some sense. And as Jeff said, we should be able to capture all of that in some structured form.
Great. Sounds like there's still some
Yep.
dialogue on
And then
that.
Isaac dropped a comment in the chat. So do researchers have to be mindful of what they query since natural language queries are sent to the LLM for translation? And potentially that could be an issue. But really, I think mainly for putting in, like, for example, subject IDs into the query, right? So that would be where subject ID gets would get passed. But the queries around, generating queries around variables, assessment, things like that, wouldn't pass any protected information. So
Great. I'm lots more to there's some job security and conversations to continue. That's great. Hopefully we will have more time to do this. Just want to say for the record that our next webinar is June 5th. It'll be Hugh Garavan from the University of Vermont. His official topic's not announced, but it'll probably be something to do with ABCD or HBCD or drug use in adolescents or things of that sort. So we'll look forward. Stay tuned. And so thank you all for attending. Thank you, Jeff, for the wonderful overview. And hopefully the community will continue our dialogue around this topic for the next foreseeable future.